In this video, we're going to continue modeling with quadratic functions. We are going to skip down to example 4. This is a real-world problem based on agriculture. You can see that there's a little graphing calculator there, so you're going to want your graphing calculator. So the situation is that researchers compared protein intake to average shoulder and kidney weight for a group of pigs. And the results are shown in this table. We're going to use systems of equation to write quadratic models for the shoulder weight S and the kidney weight K as a function of the protein intake. So as a function means that P is going to be our input. So these, think of this as like our independent variable. And then we're going to write two functions. One of them will be shoulder weight based on protein intake. So we'll call that S of P. And the other one's going to be kidney weight based on protein intake. And so we'll call that, how about K of P? Now, they asked us to use systems of equations to write the quadratic models, and we just did that in example 3. This is using systems of equations, where you write 3 equations in 3 variables, and you use systems of equations to solve for those 3 missing variables. And in this one, we use A, B, and C. And for quadratic models, it's always going to be A, B, and C. However, I'm going to show you how to use your graphing calculator to do that super quickly. So again, we're going to have 2 separate equations, S of P and K of P. We're going to use our graphing calculator, and we're going to use a method called quadratic regression feature on the graphing calculator to make this kind of easy. So get out your graphing calculator. First thing we're going to talk about is that, all of our inputs, so all of our x's are going to be that row. Okay, so what I'm going to end up doing is I'm going to make what looks like an input-output table. But instead of x and y, for example, for my first equation, it's going to be P and S of P. Okay? So go to your graphing calculator. You're going to go to Stats. And in Stats, you're going to hit Edit. So that's number 1. Now, I already have a list here. And if I want to clear my list, I can go up to L1. So if you already have stuff in there, go to the very, very top, and you're going to hit Clear. And now you have a totally blank list. Now for my list 1, these are going to be all of my inputs. So I'm going to start by putting in all of my P's. So 195, and you just press enter. 238, and you just press enter. 297, 341, 401, and 427. Okay, now for my L2, that's like my Y's or my outputs, or in this case, if I do the shoulder weight, that's my S of P's. So I'm going to go back up to list 2, and my first shoulder weight was 8,130. Now I'm just going to enter these in. And I'll do one at a time with you guys. So right now we'll just focus on shoulder weight. So let's talk about what I did first. So my first step is to make lists. And the way that you do that is you hit the Stat button, and then you go to Edit. And basically what I did was I made an L1, which are my inputs, and an L2, which is my outputs. So the second thing we're going to do is we're going to plot our L1 and our L2, or our inputs and our outputs. So second thing is make scatter plot. You're going to go into your graphing calculator. You've got your list here. And you're going to try and graph this. Now this might turn out weird, so let's see what happens. So you hit graph. And you're like, I don't see these points, right? These points from this input-output table that I've created, these lists. I don't see these points anywhere. So let me go back to my list real quick. When I look at this list, I should have points that are like 195, 8,130, right? So those are pretty big points. And when I look at my window is showing me that my x max and my y max are 10. Well, let's see, my biggest x value or input value is 427. So maybe my largest x value, I'll make 500. How about 510? Okay, and then my largest output is 9,810. So my y max should probably be somewhere around 10,000. All right, let me graph it now. This is weird. So first of all, some of yours may not have the scatter plot at all. So these points that you see, those are that's the scatter plot. But I also have this line or this parabola over closer to the origin. Now that's because if I go to y equals, in y1 I have 2x squared. I'm going to clear that so that I don't see that. And if any of you aren't getting the scatter plot at all, it's because you don't have plot 1 selected. Okay, so we should have plot 1. And if you still don't see anything, you may have to hit second y equals or second plot to tell it to, first of all, turn on, but also to tell it, you see this list 1 and list 2, you have to tell it to use for the x values list 1 and for the y values list 2. Okay, so back to my scatter plot. There's my scatter plot. I can see that every point in my list is represented. Okay, so let's go back to, so a couple things to think about in your scatter plots. First thing is you might need to change your window. You might need to clear your y equals. And you might want to, or you might need to select plot 1. All right, so the next thing we're going to do is quadratic regression. This is actually quite easy. So the way that you select quadratic regression is you go to Stat, Calc, and then you look for quadratic regression. And then calculate. I don't think this one that I'm using has the calculate button, but for you guys, you'll want to go down to calculate and press enter. All right, let's check it out. So we're going to go back to this. Okay, we're going to go to stat. You guys see the calc, you got to go over 1 using your arrows. And then you want quadratic regression, which is number 5. Press enter. You should make sure that your X list is identified as L1 and your Y list is identified as L2. And you can also see down on the screen, or sorry, down on your touchpad, there are above like number 1, there is an L1. So if you didn't have an L1 under X list, you could hit second L1 or second 1. Okay? So that's just another, sometimes your calculator will do funny things and you have to know where to find everything. All right, so for me, I don't have a place to select calc or calculate, but for you guys, you will have a place to select calculate. I'm just going to hit enter. And look at this, it's going to give me my A, my B, my C. Okay, so A is negative 0.080. And B is 55.2, and so on. Okay, I'm going to write those down. So for S of P, our A is equal to negative 0.08068. Our B is equal to 55.2286. And our C is equal to 330.3796. So my function for S of P will be negative 0. Now I'll just go 3 decimal places. So 081x, oops, not x. our input here is p. So p squared plus, and then I'll go 55.229 p plus 330 point, how about I go 38 since I need to round up. There's S of p. And now to do k of p, I'm going to do the exact same thing. So what I have to do now is I have to go back into my list, and for list 2, I'm going to use the kidney weights instead of the shoulder weights. So go back to stat, go back to edit, list 2. There's ways to do this. You could make a whole new list. I'm just going to go ahead and clear this one, and I'm going to put my data in for list 2. So these are the kidney weights. Okay, I'm going to do the exact same thing where if you look at the graph now notice my window, I could change this, and I can change my window a little bit smaller. I don't need such large outputs. Maybe I'll just go to 500. And there's my scatter plot for the kidney weights. Now I'm going to go ahead and do stat, calc, and I'm going to go down to number 5 for quadratic regression. And I think there's my new numbers. Okay, so I'm going to go ahead and write these down. Oh, I should tell you. So we have negative 6.09, but times e to the negative 5. So that's like scientific notation. So they don't use times 10 to the negative 5th. They say e to the negative 5th. So that means I need to take my decimal place and move it back 5 decimal places, or I need to add 4 zeros in front of that negative 6. I think everything else is good, so I'm going to go ahead and write that stuff down. So for A, we've got a negative, and I said I'd add 4 zeros in front of the 6. For B, was 0.626, and C was 125.16. So my K of P equation, or the kidney weight as a function of the protein intake, will be negative 0.000061. You could actually just go 6, because I've definitely gone to the thousands place and beyond. P squared plus 0.626 P plus 125.16. All right, and so there's my kidney weight function. Now what I'm going to do is I'm going to take this function. I'm going to show you how you can double check that it actually works. So now go back into your calculator and go into y equals. I'm going to put my function for my kidney weight. I'm going to go ahead and put it in for y1. So my kidney weight was negative and 4 zeros, and I'll use x squared, and then plus 0.626 x, and plus 125.16. And now if I graph this, the scatter plot and my actual function polynomial graph should overlap. So the calculator does a really good job of drawing a line of best fit that goes through the scatter plot. It should look more like a curve of best fit. Our overall graph should be more curved if it's going to be a parabola. However, in this context, it doesn't really make sense to feed the pigs too much or to have too large of a kidney weight. However, I can change my window and get a little better idea of if this actually is parabolic in nature. So how about I increase my protein intake? So my x-axis or my horizontal axis, why don't I change that? How about, let's just try 10,000. I don't think this makes sense if we're talking about pigs eating like 400 grams of protein intake, but let's go with 10,000 and see if my graph in fact is parabolic. Okay, well I can see that it's coming down on the other side, so maybe I'll also change the kidney weight. Let's see. Why don't I change that? How about to 5,000? Let's see what that looks like. So this parabola fits our data very well. However, does it really make sense? I think this is where you would want to put in a domain and or range restriction. You can see that down in the bottom left corner, this parabola is fitting our data really well. But at some point you're going to say how much protein intake is appropriate. And maybe we've gone beyond our limits. So that would be a domain restriction. Or how much can a kidney actually weigh? And so maybe, our maximum here has gone beyond what a kidney can actually weigh. So that would be a range restriction. So you always want to think about those things. Models will fit data, but it doesn't mean that it's good throughout the entire model or throughout the entire time. That's where you bring in those domain and range restrictions.